Hey, what's up, fellow Technoids? Elric Ferris here once again on the Motherboard.org YouTube channel, bringing you guys another really cool tutorial with my co-host, JJ from ASUS. Today we're going to be taking a look at the world's first certified Thunderbolt motherboard. With that said, let's check this out. Okay, JJ, so right off the bat, the first thing you're going to want to know is they're going to want to know what is Thunderbolt technology. We all know what Thunderbolt's a little thing that comes out of your wizard's head in Diablo 3, but what is it when it comes to technology? So that being said, why don't you introduce that and let the audience know what Thunderbolt is from a layman's point of view?
Definitely. I think you bring a lot of good context in terms of what you just talked about there, is that what makes Thunderbolt unique. One of the things that we're always passionate about is being a board vendor is bringing new features, new functions, new technology onto our series of products, and we're definitely happy to do that here in terms of the premium board, right? But we're talking about something really special and a brand new input-output and interconnect. This generally doesn't happen a lot. I mean, in your experience working with a lot of boards, you've seen that you get things like USB, eSATA, FireWire, different protocols that come out, but generally it's not something where you have a huge interconnect come out, right, between, let's say, a chipset to a chipset launch.
No, you usually don't see that at all. It's usually once it's been out a while and been iterated, then you see it, but not right out of the gate like you guys are doing.
Right, so that's one of the really big things that we have here. So this is, of course, Thunderbolt now enabled on the PC platform. So Thunderbolt was previously called actually Lightpeak, for some people that might have kind of been monitoring it for a while and wondering.
The Mac folks?
Yeah, well, even just as a whole, the code name internally from Intel in terms of its development team was called Lightpeak. And now we're actually with a final name, which is Thunderbolt. So Thunderbolt is an actual input-output connection. In terms of what makes it unique, there's a lot of aspects that make it unique. It's ultimately been designed with kind of three core tenets about performance, simplicity, and flexibility. So those are kind of the three things that they kind of went in with their mind in terms of developing and saying, hey, we want to make an internet that meets all these parameters.
It's actually plug and play at a whole new level, correct?
It's not just plug and play, but it's taking a performance and flexibility to a whole nother level. And we're going to talk a little bit more about that. So with this, one of the first things that we want to talk about is the ultra-fast performance that it offers. This is essentially taking an internal PCIe link. It's a by 4 express PCIe link for the Thunderbolt controller, and that's going to be enabling 10 gigabits throughput upstream and downstream. So that, when you compare that to USB 3, that's a huge increase in terms of the performance.
Because that's only 5, correct?
That's correct. So you have double the effective throughput that you had on the USB 3 controller, but on top of that, you also have the ability to pass through not just PCIe-based data, but you also have the ability to pass through the DP signal. So DP signal is going to essentially be your DisplayPort signal, so that gives you the flexibility to be able to run high resolution, 2K, 2560 by 1440, 2560 by 1600, along with passing up to 8-channel audio. So it's a very flexible standard when you compare that to especially some of the other input-output connections like eSATA or USB 3, which USB 3 does have the ability to pass through video, but there's some latency issues as well as some audio and video synchronization issues that can sometimes occur, where the Thunderbolt specification from the ground up has been designed for low latency and for audio and video synchronization and timing, because this is something that really is going to be well received by the content professionals out there, people that are doing high resolution photography, audio, video, and whatnot. This is going to be a great interconnect for them.
And all that huge bandwidth that you have actually translates so that when you have all these external devices, when you're hooking them all up, they all get to take advantage of that throughput without losing any performance degradation with that large of a capacity rate, right?
Yeah, that's correct. That's one of the key things, is they wanted to make sure that that's linked in and always has an active connection. And that's even more so prevalent here on our board, where not necessarily all Thunderbolt boards that will be on the market will actually always have a by 4 interconnect. So that is something to kind of be conscientious of, is that there could be configurations where even if there's a Thunderbolt header on the motherboard, it might be powered by actually a lower interconnect. But ideally, even in, let's say, a by 2 interconnect, which could be the minimum of what Thunderbolt is enabled with, you still have very, very high throughput that would actually exceed generally USB 3's performance.
Oh, and the motherboard that we're talking about today, folks, that is the new P8Z77V premium motherboard that we got sitting right down here in this box. So to clarify for you folks out here which motherboard it is, this is the one.
Yeah, and you actually make a good point with that, while we're focusing here on the premium SKU, we will actually be coming to the market with a Dash V Pro board with Thunderbolt as well at a lower price point. And we'll get later on to further discuss some of the other options that we talked on some of our Z77 boards that have the Thunderbolt header when we can talk about that at another time.
The future.
Yes,
the future isn't here yet.
So moving past that, here you can see that we're actually showing you a little bit of the actual kind of breakdown in terms of the way that the implementation works, where we have PCI Express and the display port being passed through the actual Thunderbolt controller, a tunneler, to then being essentially externally enabled by PCI Express and Thunderbolt. So this is helping you to see that essentially it's keeping those two paths independent and being able to provide that data and that throughput through the implementation that's at play.
It looks like, though, that there's a lot of devices that are going to be implemented to actually support this technology in the future, since it's being such a big push.
Yeah, and that's really where a lot of the flexibility comes into play. With the bandwidth that they have and the fact that it's PCI Express, essentially any of the internal controllers or the internal implementations you have right now working with PCI Express could essentially become external. So right now we're focusing on storage, but this could be enabled for external network, external sound, external even graphics enablement. So you got a lot of flexibility.
Chain, correct?
Yes, correct. So a lot of flexibility you have there. So you know, getting back to, once again, some of the key features, right? We've got the 10 gigabits throughput. It's bi-directional. You've got daisy chain compatibility. It also provides power. That's also one of the key points where, just like the USB spec, it's also able to provide power. Now, this is something that some people have been confused about in terms of that there's an optical cable and then there's an electrical cable.
Okay.
Now, there are two different standards when that comes into play. With the electrical standard is right now what's going to be most commonly utilized. That can provide a length of up to 3 meters. And from the host controller, so the motherboard, 15 watts down to, let's say, a single device like what we have right here. This one has a single port on it, as you can see right here on this little guy. That would receive up to 10 watts.
And just for the audience, what is this device here? This is a Seagate. What is this one again?
This one's a Seagate GoFlex. So this is actually a Thunderbolt, a low-cost adapter. It's about $80 to $100. But this is a great entry-level solution for people that want to take advantage of the high-speed performance. They could take an SSD, put it on here, and be in excess of 300 megabytes in terms of the throughput, even over the performance you generally get with a USB 3 device.
Which is excellent.
Yeah, very, very cool. And lastly, one of the other key things that we have is, like I said, the low latency nature of Thunderbolt, which really lends itself towards, you know, content professionals, multimedia professionals. So with that, let's talk a little bit more about the architecture and how that's actually going to play into the next thing that we're going to cover, which is going to be daisy chain and hot plug. But some users have wondered, well, how does this work in terms of interfacing with the motherboard? There's a link in terms of the PCI Express controller and what's called the system link controller. These two pieces of data essentially exchange the operating modes of the board. So you know when your board goes into like S1 or S3, S4, it's going to like sleep or hibernation, right? The motherboard has to be able to send that information over to the Thunderbolt controller, and then that also has to then be passed over to your external devices.
Through all the devices, correct?
That's correct. And that's important because overall we want that information to be negotiated and handled correctly so that if your board was to go to sleep, right, your hard drives also go to sleep, right? So that way we help to minimize wear, we can reduce power consumption and things along those lines. And so there is some additional complexity in not it just being a controller that you throw on there, but also some architecture in play to make sure that efficiency comes into play.
Okay.
So with that, here we're going to talk more about the daisy chain and the hot plug functionality. There's been some confusion about users wondering about, well, can I actively plug things in? You know, can I support multiple devices? So here in our initial setup, we have one motherboard, one lusty little big disk, and then one monitor connected. So what we're going to do here is we're going to show you live that we can go ahead and essentially connect other devices, including the display, and have those all link back up.
Yeah, true hot swap availability.
Yep.
All right, let's see it, folks. All right, folks, so here we go. We're going to show JJ live hot swapping these drives on the new motherboard. Now, currently we have a single LaCie drive hooked up and the DisplayPort monitor. What JJ is going to do now is he's going to hook up 4 of the LaCie drives and the monitor all at one time and show you how it interfaces in real time. So right now, JJ's disconnecting everything.
Yeah, I've disconnected just the DP monitor, so I've removed that from one of the LaCie drives.
Okay.
I'm going to go ahead and use the same cable that's coming from the motherboard, and I'm now going to go ahead and leave that connected to one disk, and I'm just going to take the other cable from the other disk and plug that into the first disk, and I'm now going to plug my monitor into the last little big disk. And that's an important point that we'll cover a little bit later in terms of some of the cable flexibility options. So at this point, we're now going to let it go through its hot cycling, and we can see that now it's
the monitor's turning back on. Everything's just like it was previously, with no change except for we have more drives hooked up. Okay, folks, so you guys saw JJ hook all those up in hot swap technology, but now let's talk a little bit about how we connect the devices, because I know you guys are going to have questions.
Okay, so you've got a couple of different permutations in terms of how you can have hot swap enabled, as well as we want to talk a little bit more about how the hot swapping actually occurs, because there is some complexity that has to occur in terms of the operating system, the actual UEFI, and then possibly even device drivers that might need to be there to help to extend the hot plug or the daisy chain functionality. So first and foremost, the connectivity. Now, in terms of the actual connection formatting, right, we have a Thunderbolt cable, which could go from the motherboard to then a Thunderbolt enabled device, right? And then that could go also to a Thunderbolt enabled monitor. Currently now in the PC ecosystem, there is no Thunderbolt enabled monitor, so this isn't necessarily a realistic configuration, but it could be a future one once monitor vendors, whether it's ASUS or other companies, come out with a Thunderbolt
so
monitor.
Currently then, the monitor is the last device in the daisy chain.
That's correct. That would generally be the advised configuration in terms of having the monitor be the last device in the chain. Okay. The next option would be Thunderbolt cable to the actual storage device, and then taking a mini DP cable and then going directly to a mini DP monitor. So that's pretty straightforward. Okay. Lastly, you would have Thunderbolt cable to the storage device and then taking a mini DP cable on one end and then going to a full DP header and then going to a DisplayPort enabled monitor. So those are all kind of your different configuration parameters, and what that ultimately ends up meaning is that the Thunderbolt header in itself is technically also a display output. So when you're counting essentially the digital outputs on like our premium board, we have that mini DP or Thunderbolt port, we then have a full display port, and then we have an HDMI port. And actually with technically having two mini DP ports with the Ivy Bridge processor, we can actually drive 3 panels simultaneously, all just from the integrated graphics core as well.
Now, currently, is there a limitation to how many drives or how many devices can be in the daisy chain off the Thunderbolt?
Yes, correct. The maximum that you have in terms of support is up to 6 storage devices, with 7 technically being present across all if you include the monitor.
Okay, so let's get straight for the audience. That means you can hook up 6 external hard drives, and at the end of that daisy chain, you can hook up a monitor, having a total of 7 then.
That's correct.
Okay.
Mm-hmm. Okay. To clarify, some people, you don't want to necessarily count it from just drives, because as an example here in these little big disks, they actually take 2 drives inside of each one, or there might be, let's say, like a Pegasus RAID enclosure from Promise that actually could take 4 drives or 6 drives, and you could have 6 of those. So you could actually have a whole lot more than just
so it's not a drive limitation, it's actually just a limitation of per unit.
Correct.
Okay.
Correct. Mm-hmm. Okay. So from there, we want to kind of talk about a little bit on some of the performance-related metrics that you've talked about, and then from there we'll move into some of the kind of specifics in terms of ASUS, how we've incorporated some special design elements in terms of helping to extend special enhancements for the performance as well as the functionality for Thunderbolt. But with that, let's get to, I think, what a lot of people are interested in is how do things compare when we're talking about USB to USB 3 to compare it to Thunderbolt.
Yeah, because so far we've seen the flexibility that it can daisy chain, and now we want to know what benefits we're going to get from switching from that type of device to a Thunderbolt. So let's jump in and let's see that.
Okay, Doc, so we're going to go ahead and show here some of the performance numbers that we've run on our setup that we have. So first and foremost, what we went ahead and did is we took essentially a high-speed, just standard USB SSD adapter. We went ahead and used that adapter, and we ran baseline USB 3 performance from the Intel USB 3 controller.
All right.
Okay, and we had really great results. Peak performance was about 290 megabytes on the write, and then approximately about 260 megabytes for the read. So definitely nothing to scoff at. Very solid performance. And then next from there, we did kind of an apple-to-apple comparison. So same thing, we just took our GoFlex with an SSD, single drive, and compared single drive to single drive performance.
Alrighty.
Okay. And at that point, we can see that we've already had an extended level of performance. Here on the right, we now went up to 351 megabytes, and then to the read, 382 megabytes.
And that's just from basically using that as the adapter instead of the USB, correct?
That's correct.
Great performance gains.
Using the same exact drive. So the delta here is more so the interconnect and the controller that we're utilizing. So that shows you in itself, there's a big performance uptick. Now, one thing that you'll see here also in the numbers is that we actually extended the Q depth performance much higher. We went to a Q depth of 10. Now, this is one of the key areas that Thunderbolt is also much more robust than the USB protocol. USB is limited to essentially a Q depth of just 1. So it effectively can only take kind of 1 read or write command at a time.
At a time, exactly.
Right. With actually Thunderbolt, it supports multiple Q depths. So this is great, especially for content professionals that are working off the external disk. Maybe you want to have an external scratch disk, maybe you want to have an external workflow. Even if you're maybe doing simultaneous read and writes, doing multiple backups, the drive is going to be able to maintain a much higher level of performance because it can essentially accept multiple commands, whereas the bot protocol that's used for most commonly for USB is far limited to essentially only taking one command.
Yeah, that's going to come into a lot of big factors when people are using a lot of different devices at the same time. That's going to benefit them a lot.
Especially in that daisy chain configuration, that's also why queued up the performance is also really special, because essentially you could still be writing to multiple devices but still having a really high performance marker. Whereas I'm sure you've probably tried to write maybe multiple files to a USB drive when it's plugged in, and the performance really tapers off.
Yeah, the more that you transfer, each one just keeps slowing down and slowing down. So basically with this, it should never do that at all because the bandwidth's available. Just keep talking back and forth through all those multiple channels.
Correct. Much better performance. Now lastly here, we've gone ahead and taken an aggregated level of performance. So if we take a look, right, we went ahead and we have our primary D drive, right, which is unified essentially. We went ahead and software rated all those drives together to even extend the performance further and try to approach that 10 gigabits throughput. And we can see that we got some really outstanding performance markers. So now our maximum write performance was 625 megabytes. And then our read performance was just a little bit over 900 megs. So a really huge level of performance that we have through an external storage array.
Yeah, almost as just like RAID when you RAID 0 with SSDs.
Yeah, and the awesome thing about that is you really get into a huge level in terms of the performance that you're offering, especially for high-end content professionals. So if like you're talking about like 2K video, that could be all done on the fly externally. So a lot of flexibility. And the interesting thing is that we're probably actually dealing with more of a controller limitation at this point in terms of those external devices not being able to keep up with the flash and being able to even offer us the best read and write performance.
But as time goes by, those devices should improve and thoroughly using all the bandwidth in the coming future, true?
That's correct, exactly. So in our test labs, we've actually had even a little bit higher performance with maximum read performance approaching almost 1 gig and with the actual write performance going almost a little bit over 800 megabytes. So really impressive performance that you have here with Thunderbolt. So with that, let's go ahead and round out some of the kind of special design details that we have on our boards. Okay, so as you can see right here, we actually have some electrical breakdowns in terms of the actual design and the trace layout for the motherboard. For some people that are not familiar, the traces essentially are the let's say the links that we essentially put onto the board that create connection points between different controllers, different ICs, or different parts in the motherboard.
And you guys have been doing a lot of this. I've seen that also on the Republic of Gamers motherboards with the sound controller as well. So
that's correct.
Technology, right?
Yeah, trace design is always something that we really pride ourselves at ASUS. We bring a lot of attention to detail in terms of helping to extend performance, reliability, functionality, things along those lines. Now Thunderbolt really added a lot of interesting kind of elements into the design because it's such a high-end controller in terms of the bandwidth that it offers, as well as the complexity of having to account for things like compatibility initialization, hot plugging, daisy chain support. A lot of sensitivity can occur if you incorrectly implement it, and so we need to do a lot of things to really try to maximize and ensure that we keep high performance, high compatibility, high functionality.
For users out there, a lot of times you see a motherboard and you hear like a weird hum on it. You guys might have heard this in the motherboard. That's when the electronic components haven't been separated well enough and you're getting signal noise. What these guys have done at ASUS is they've made it so this is completely separated so that the noise level on it is almost completely zero.
Yeah, we've done a lot of work in that regard. So you can see here in terms of the actual trace layout, this is one of the key areas where you can actually see in terms of the Thunderbolt trace, the area around it is very clean. And that's critical in terms of helping make sure that we're not allowing interference or noise to come in and affect the overall functionality of the Thunderbolt link between the port on there as well as the actual Thunderbolt controller that's on the board.
Now, what makes the Thunderbolt trace? I see that the Thunderbolt trace has like a curvy design, kind of like a wave, where the USB 3.0 trace is very much like hard angles. How does this actually translate into making the board quieter and better running?
Well, in terms of what you're referring to like quiet, is that we're helping to minimize signal reflection. So this is all electrical measurements. What we're trying to do is have very, very clean measurement patterns that also translate into what's called the eye. The eye is a form of electrical margin in terms of helping us know where the performance is at signal integrity and all the things that apply with signal integrity. So here you can see that we've utilized an arc shape, really smooth shape, to help to maintain the best routing path between the actual port and the actual controller. And here's some additional detailing showing you some of the additional steps that we've taken to make sure that we have this implementation be as let's say effectively placed as possible and not be impacted by other componentry. And lastly here's some of the eye measurement data to show you the performance that we have not only on the Thunderbolt implementation itself, but also the DP enablement. Because remember, with that port, we're having both the display port and the Thunderbolt connection work.
So in this particular screen that we're looking at, JJ, what we're basically seeing here is the color scheme that we see inside of the top picture compared to the one on the bottom that has a bunch of different colors in it. That means the top one's running a lot clearer. Is that what that's translating
well,
into,
these
basically?
are actually two different measurements. So they're both from the same port, but they're for a different electrical test. So we're showing you that the actual margin, the performance that we have is really, really high for both of the implementations. One for the Thunderbolt and one for the actual electrical test for the DP link. So overall, that gives a little bit more kind of, I think, transparency to the attention and detail that we're bringing in terms of Thunderbolt on our premium series board.
Okay. So then basically, folks, at the end of the day, what you get with Thunderbolt is you get massive flexibility, higher throughput for your bandwidth. You can see you can use multiple items in daisy chained, and at the end of the day, it's performance and it runs quieter than standard earlier technology. So that's pretty much it. I mean, you guys are the first to have it. We got to salute you here at motherboards.org and welcome everybody to the wonderful world of Thunderbolt.